Good afternoon, class 10. Have you counted how many days are left for SE? Remember, time and tide wait for none. Jindagi does not remain always ah ooh, papa poo poo, kha cuckoo, dada doo doo. Right? There must be focus, concentration, and practice. Okay, today I can see here Sujan Rokaya's presentation, Ritika Morgan's, and who is next? That's a sizzle star. It means today's presentation presentators are Sujan Rokaya, number one, Sasank Acharya. The slide is made by Ritika. I think there must be some problem in his laptop or somewhere else. And third one is our presentator, who is that? Srijal Karki. So let's welcome. Do you have any this what to say? Animation? No. You the animation? Srijal animation? Okay, Srijal's animation, but others no animation. So Srijal's slide let me download it. So Srijal star. Okay, Srijal star downloaded. I will download all, then it will be easy. Okay. This prevented everybody see right. Okay, this also let me download. Also, pressure one downloaded. Pressure. So that is of Sasank. Okay, Sasank. Now Sujan Rokaya, I have to download on off thrust. PDF. He made PDF. Why? Oh boy. Okay. This introduction to off thrust. It is of Sujan. Sujan, yours?
Yes, sir.
Very good. Please, keep silent.
Good afternoon, everyone. As you all know, I am Sujan from class 10. Today I am here for present about off thrust. Without doing delay, I would like to start my topic. Introduction to off thrust. Off thrust, also known as buoyancy, is a buoyancy is a fundamental principle in physics that describes the force exerted by a fluid on an object impressed in it. This invisible force is crucial in understanding how objects float, sink, or remain suspended in liquids and gases.
You come, you decide and explain. Yeah, come decide and explain. On reading sentence or matter, explain what it means.
By upthrust, how we can learn that how the that ships ships and that what we call that in Nepali dunga are floating. Uh, float we can learn by upthrust.
Then you clear slowly.
Definition and explanation. Upthrust is the upward force that a fluid such as water or air exerts on an object impressed in it. This force is caused by the difference in pressure between the top and bottom of the object, and it acts to contract the object's downward gravitational force. Up, Upthrust is upward force.
That underline and then show that. It will be better. Yeah, highlight.
You know that upthrust is upward force, which is that of a fluid that exerts on an object impressed in it. The difference in pressure between the top and bottom. This force is caused by difference in pressure between the top and bottom. It is uh, it is caused by difference in pressure between the top and bottom. First affecting of thrust. Factor affecting of thrust. Density of the fluid. The factor which affect of thrust is number one is density of the fluid. The denser the fluid, the greater the of thrust force. Volume of the object. Another one is volume of the object. The larger the volume of the object, the greater the upthrust of force. If volume is sir,
Okay, gone?
come,
Yeah.
came. The larger the volume of the object, the greater the upthrust force. If there is large volume, then upthrust is also upthrust force is also greater. Depth of immersion. The deeper the object is submerged, the greater the upthrust force. Archimedes principle discovery. The ancient Greek mathematician Archimedes discovered the principle of upthrust while taking a bath. One scientist from uh, Greek mathematician Archimedes discovered the principle of upthrust while he was taking bath. While he was taking bath, it is mentioned here. Sir, it is
Now wait.
here. Explanation. Archimedes' principle states that the upthrust force on an object is equal to the height of the fluid displaced by the object. We know that as per the Archimedes principle that the upthrust force on an object is equal to the height of the fluid displaced by the object. It is mentioned here. Sorry, of this one. Principle of applications.
Practical application, right?
Practical application. Buoyancy of thrust allows objects to float on the surface of fluids, enabling ships, boats, and other watercraft to stay afloat. After by the help of thrust, ships, boats, and other watercraft can able to float on the water surface. Density measurement. Author is used to measure the density of object by comparing their weight in air and in a fluid of known density. Author is also used to measure the density of objects by comparing their weight in air. Hydraulic engineering. Understanding the upthrust is crucial in the design and construction of dams, bridges, and other hydraulic structure. As you all know that most in engineering, upthrust is also important to design and construct of dams. With the help of that upthrust, engineer can able to design and construct the dams and bridges and other hydraulic structures.
Huh?
Done.
Finish?
Another.
Hello,
I might think.
listen.
We can calculate upthrust in weight, the weight of the object impressed in the fluid. We can also measure upthrust in volume, the volume of the object impressed in the fluid. We can also measure the upthrust by using fluid density, also from formula upthrust equal to fluid density. We can also calculate upthrust in formula upthrust equal to fluid of density into volume into gravitational acceleration. Upthrust in everyday life, floating upthrust allows us to float in water, enabling activities like swimming and boating. Balloons, hot air balloons, and other lighter than aircraft rely on upthrust to stay afloat. Balloons, which are hot balloons, like which are used for uh, which are used for that say, fly is depending on upthrust to float in air. Divers use their understanding of upthrust to control their buoyancy underwater. Di- diver also use upthrust to control their buoyancy underwater. Density comparison. Upthrust is used to compare the density of different objects such as in air floating experiments. Uh, Conclusion and key takeaways. Upthrust defined. Upthrust is the upward force exerted by a fluid on an object immersed in it. Upthrust is upward force exerted by a fluid on object immersed in it. Upward force, which is using that which is come upward to the upward surface is called upthrust. Factors affecting upthrust. Upthrust is influenced by fluid density, object volume, and depth of impression. Practical application. Upthrust is crucial in understanding buoyancy, density measurement, and hydraulic engineering. Thank you.
Thank you. Yeah. First one. You can do from here, or you can do from book. Book here, then I'll just books. Book up and down.
So, namaskar everyone. So, I'm going to tell about the upthrust. So, upthrust, when a body is immersed in a fluid, when the body is partially immersed in fluid, the force affected by that fluid is called upthrust. To understand this, we can see this figure. So, in this figure, there is one cube. So, in this cube, there is showing arrow of lateral thrust. So here you can see this here. It is indicated by the sizes error. As the lateral sides are equal object, it will be equal and it will be 0. So what this difference is significant. Downward thrust and upward thrust are different. So you can see here. But due to the significant difference in the depth of upper and lower surface, the amount of upthrust and will be greater than the amount of downward thrust. The difference in these two thrusts is upward thrust and the give thrust. When a body is partially or wholly immersed in the fluid, the force exerted by the fluid is called upthrust. So upward equals to upthrust minus downward thrust. So here is how we can measure the upthrust. So objective to measure upthrust, a spring balance is shown, and overflow a beaker, a piece of stone, and a piece of string. So in here, once there is two spring balance. So take the stone tie with string and suspending on a spring balance as shown in the figure A, and record the weight of the stone in the air. Let the weight of stone be 50 Newton. So immerse the stone completely in the beaker containing water. So as shown is the figure, let its weight in the water be 230. So now the loss of the weight by the stone is W weight 1 minus weight 2. It is 50 minus 30 is 20 Newton. Certain. So factor of upthrust. So upthrust mainly depends on three factors. One is volume of the body. Second is acceleration due to gravity A. And third one is density of fluid. So in these three factors, the upthrust is depends. So
Now we can write.
So here you can see the formula F1 equals to P into A, F equals to D into G into 1 equals to P equals to D into G into H. The thrust acting on the CD surface is F2, P2 is into A. So yeah, therefore the net upthrust on the cube is given by the difference in upward thrust F2 and downward thrust F1. So up thrust equals to F2 minus F1, up thrust minus down thrust dh h square A minus dh1 A, or U equals to D into G into A h2 minus h1. Therefore F2 minus F1 equals to U equals to D into G into V equals to A into H, volume equals to area into height. Thus the thrust, force or upthrust is polar of density of the liquid, the volume of the liquid displaced and the acceleration due to gravity. This equation is also known as the law of buoyancy, means upthrust. In this principle, in the next section, it depends on the three factors. Three factor: volume, density, and acceleration due to gravity. This height is filled with air. So it is contain low density air. When the low density air differs from the outer air, so the hot air balloon flies, and so you can see this here. The immersed part of the balloon, the floating mechanism of ships and boat is also based on this. So when the ship lower part is immersed in the water equal to the volume of immersed part. When the weight of the displaced liquid becomes equal to the weight of the ship or boat, it floats. Because of this reason, when a ship or boat is loaded with cargo, its hull sinks more and more. So here is given the figure of hydrometer. So hydrometer is a device which is used to measure the density of liquids. So it consists of glass and a bulb at one end. So which is partially filled with lead salts to keep it vertically positioned in liquids. The salts are waxed over the ball. So the hydrometer has a wide evacuate body and a narrow stem with the scale marks. When it is placed in any liquid, it displaces the liquid equal to its weight, creating buoyant force or upthrust force on it. The hydrometer remains vertical in the liquid due to heavy bulk. In these conditions, we can know that the scale on the stream which remains at the upper level of the liquid, the hydrometer used to measure the density of liquid is called lactometer. Sure. Okay, thank you.
Thank you very much. So, I think we have very this swimming, sinking protein, submarine, architect principle. And then that much is 1%, and it's principle of rotation. Empirical problem, another one, right? Okay, so today, no, tomorrow, no, Tuesday you done. So now we'll do little, so yeah, Tuesday, so that they have to study. Immerse in liquid, the liquid applies force to that object upward direction. That force is called upthrust. Last time I told you, when any object is immersed in liquid, two type of forces are acting on it, right? One is downward force, that is called, what is it? Gravity. Upward force, what is it called? Upthrust. Then what is the SI unit of upthrust? Yeah. Upthrust is force. Upthrust is force. In which unit is it measured? Newton. It is force means it is expressed in Newton. You have to remember, right? So here is given factors of upthrust. The diagram shows here. This lateral thrust, downward thrust, upward thrust. So this lateral thrust is equal and opposite. That's why it's balanced. Upward thrust. First of all, downward thrust is F1 equals to dgh1. Liquid. Okay, one thing you have to remember. What is the formula to calculate pressure? P equals to F by A. P equals to F by A. This is the formula for solid pressure, isn't it? For liquid pressure, P equals to dgh. What is D? Density of liquid. What is G? Acceleration due to gravity, I. But once again remember, P equals to F by A is there, right? P equals to what is there? F by A. If so, P means what is the formula? dgh equals to F by A. If so, what is the formula of F? dgha. That's why it is written here. F1 equals to what is given here? dgha. But h1 is given. This height is here h1. And for this second one, what is the height? h2. That's right. Downward thrust F1 equals to dgh1a. Upward thrust is how much? dgh2a. h2 means height is different. When you subtract, upthrust equals to F2 minus F1, dgh2a minus dgh1a, then dga common, h2 minus h1, then h2 minus h1 is height. Then what is the formula to calculate upthrust? U equals to B dg. What is the formula? What is B? Volume immersed. What is B? Volume immersed. What is D? Density of liquid. No, depth. Density of liquid. What is G? Or it can be written here as just that much only, right? These things we have to remember here. Right? And next thing is, where can we apply upthrust? Upthrust can be applied in different places. Where? Balloons, ships and boats, hydrometers, swimming, sinking and floating, submarine. That means there is presence of fluid, and the fluid applied some sort of upward force. Yes or no? This is the time to go for swimming also. If we go in the same position, in that vertical position, is it possible to swim? But when we make it horizontal position, then we can swim, right? So our body must displace more water. More water means equal to our weight. Suppose if my weight is 1000 Newton, how much Newton? How much water should my body displace so that I can float? 1000 Newton. But in this position, less, because volume will be less. Volume is less or not? But in this position, volume will be more. So more volume, more upthrust. And here is given the factors affecting upthrust. What are they? Volume of immersed part of the body. What is next? Density of the liquid. Acceleration due to gravity. Here is given hydrometer. One diagram, let's see. Can you see here one device? So here is one container. or let's say it is a beaker, right? Cylinder also we can say. What does this cylinder contain? Liquid. And to measure the density of that liquid, one device is kept. It is a bit heavy, upper side is light. And if the liquid has more density, it sinks less. But if it has less density, it sinks more. And this reading is here, up to where it shows. And there is a special type of hydrometer that measures density of milk, that is called lactometer. The device which is used to measure density of liquids is called hydrometer. Density of water is called hydrometer. But the special device which measures density of milk is called lactometer. So, lactometer, not lactogen. What is this? Lactometer, right? Lactometer is there. So, in swimming also we can see here. Swimming fish. So, their volume should be more or less. More volume, more of thrust. Less volume, less of thrust. And one thing see here, in ship. What is ship? Ships and boats are here. If the ship or boat contains less weight, then it sinks a bit less, right? But if we add here more and more load, then its hull, lower part goes more down, because it has to displace more water. It has to experience more upthrust. Okay? I think that much is discussed today, right? So in tomorrow's class, Sasank Acharya will explain more than this. Everybody take out your book, take out your copy. First read this portion and make note. Okay? Please, thank you.